computer systems, it is necessary to provide a substantial amount of memory. If a system is implemented using FPGA technology, it is possible to provide some amount of memory by using the memory resources that exist in the FPGA device. A common term used to specify the size of a memory is its aspect ratio, which gives the depth in words and the width in bits, or we can write as depth times width. Now here is an example of a diagram of a RAM, or Random Access Memory module. It contains 32 4-bit words, which are accessed using 5-bit address port, a 4-bit data port, and a write control input.
And this is the implementation of the 32 times 4 RAM module. The implementation includes registers that can be used to synchronize all of the input and output signals to a clock input. The registers on the input ports must always be used, and the registers on the output ports are optional. Second, the blocks have separate ports for data being written to the memory and data being read from the memory. These requirements will implement the modified 32 times 4 RAM module shown in the diagram. It includes registers for the address, data input and write ports, and uses a separate unregistered data output port.
Now, the first step of implementing the memory block module into FPGA is to start a new project on the Quartus Prime Lite edition. Click New, Quartus Prime Project. Next, we can save it in the desktop. Memory block. And we can name this memory block B2, and the entity we will use RAM 32 times 4. You can use the default for these settings and wait until it's done, and there we go. Now we have the project. The next thing we need to do is to add the memory block. We go to basic functions and on-chip memory and RAM 1 port. We will give the name the same as the entity, RAM 32 times 4, use the VHDL file type, and we will use 4 bits as the Q output and 32 words for the words of memory. We will use the M10K memory block type, and we will deselect the key output port. We use the default for the next settings. And there it is. This is the program for the memory block, the RAM 32 times 4. It is already available during the installation of the Quartus Prime edition. And now we will add the program of the memory implementation. We'll start by a new file, VHDL file, and I have already prepared a pre-made program for this. Here it is. We use different ports, just as the same as the one in the diagram shown before. And now we will save the program. We will name it part 1. It's done. Now we will compile. We can see the progress of the compiling here. and we will wait until it's done. Okay, so the compiling is done. We have no errors and a few warnings. So the program is ready to be simulated, and now we will do the simulation using a waveform. First, we will go to the file and a new university program VWF, and then we will go to insert, node or bus. We will use the node finder and list. We will just select all these and done. Now, after we have added all the names, the address, clock, data, and queue and RAM, now we will run the functional simulation. Save it. Yes. Okay, now the simulation is done.